Hello, ladies and gentlemen. Welcome back to Math 30-2, Chapter 6, Lesson 5, Finance with Exponential Equations, Part 2. Now, once again, I want to stress this: interest for compounding period and n the number of times the interest is paid. Confusing, but I think we've done enough examples. Now, moving on. Brittany invested $2,500 in an account that pays 3.5% compounded monthly. The table gives the value of her investment for the first 5 months. Okay, value of investment, 2,500, 25/7. So 729, 1460, 2194, 2929, 3667. A couple of things to note here. First, notice how the value of the investment is going up. $7.29, then 1460, which is more than twice 729. Then it goes up 2194, which is more than 3 times 729. That little bit extra is the interest on the interest. Now, the question here is, use exponential regression to determine the compound interest function that models this situation. Okay. So the second thing you have to note is, we have to put this in our graphing calculator to come up with an equation. Careful, time is always x, which is L1. And the value is L2 for y. They deliberately do this backwards sometimes, not to confuse you, but they consider money more important than time. That's my big deal. Alright, so put this in your graphing calculator. Now I'm going to use the fancy smart one. Come on. So you got your calculator. Come on, you can do it, darling. Yes, you can. So, statistics, edit. We already have data in here. We have to clear that. Oh, sorry, my bad. Statistics, edit. Scroll over, scroll up, clear, enter. There we go. So, 0, 1, 2, 3, 4, 5. There we go. And then L2 is 2,500. 2507.29, 25.4, 6. Now you notice here, because of the number of digits, it's rounding off to 1 decimal place. It's supposed to go to 2, but it just can't display them all, so that's fine. As long as you put it in correctly, the graphing calculator will calculate that. 25.1.4. 9. This is rounding off, and 25, 36, 7, enter. There we go. Now, I really want you to graph this just in case you make a math boo-boo putting the numbers in. So, now look at our windows. X goes from 0 to 5. 0 to 5. Now, our investment started at 25 and went to 2536. So honestly, you'd go 2,500 and then 2,550 would be your final value. Probably be, oh sorry, I forgot I got to clear these. Hit enter to turn that on, graph. And there we go. Now, I've got 1, 2, 3, 4, 5. There's another one down here, you just can't see it. I can because you see the extra bit block there. Now, I need you to graph and you go, okay, that looks pretty straight. It's actually curved exponential. It's just a very, 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 very small part. But I need you to do this because if you put some number in wrong, then you know this block is down here, and it will throw off your calculations. So you can see all the blocks. You're pretty sure you got it right. So let's calculate statistics. Calculate. If this is exponential regression, enter. Enter, 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 yes. So I'm going to make note of this. 2, 4, 9, 9, 9, 9, 8. course, it doesn't copy over. 1 equals 2, sorry. 499,998. I'm going to call that 2,500. 0, 0, 2, my apologies, 916. All right. So, a couple things to point out here. This is my principal, what I started with. Now, $2,499.9989. That's 2,500. This is interest rate for compounding period. Right? Now, that you need to be able to do, because the more important question is B. How long in months will it take for Brittany's investment to grow to 3,000? So, X, Y, 3,000. Now, we've done this before. You know I'm going to talk about graphing. But before you do that, let's go back to the equation. Y equals 2,500, 1,002,916 Our Y value is 3,000, so this is 3,000. 2,500. Now, what some people will do, and what I suggest you do, is simplify this mess. Because what we have here is an equation. So, what I would suggest doing is divide both sides by 2,500 to make the number simple. Now, why do that? Well, it doesn't really matter because Mr. Calculator can handle these numbers, but this equation here, simplified, is a lot easier to graph, much smaller windows. Okay, now, does it really, really matter? No. Do I kind of suggest you do it this way? Yes, I do. Am I going to get all upset if you don't? No. All right, 1.2. Let's go. Y equals, so I go up, turn off that, no, sorry, leave that on, never mind. Decimal 0.02916 power of x 1.2, and now you're right, I know you're screaming at me, I should turn that off. Now on Windows, time, I don't care about negative time, so I'm going to go to 10 years. X minimum, 0, 1.2. For that. Now you can see my two lines here. We'll have to tell them apart, so let's cheat and make the exponential graph thicker. So you can see the exponential graph is slowly curving up. 10 is way too short. And we know that. Perfect. You can guess that. That's $7 a month-ish. So now I'm going to cheat. Actually, I'm just going to say the heck with it. I'm going to go to 100. There we go. I guess I could have scrolled down the table, but I got lazy and lucky. Let's calculate the intersection. Like I said, 100 months. Second, yes. 62.6 months. Well, it's just over 5 years, I think. We'll divide that by 12. Tell me how many months it is. Right? Yeah. Okay. 2 more word questions. All right, so my apologies. There's a couple more word questions, so getting kind of long. I'll pause here. You take a look at this. See if you can pull up the data, find the equation, answer questions based on that. This modifying or simplifying the equation for graphing, you might find it easier. If not, that's just life. Anyway, that's enough for this video. Pause here, we'll go on to the next one. Good luck.